So this is our first math on bolt connection design. So the thing is that we'll have to find out the number of bolts we need. Uh, though a reference one has been given right over here, and we have dead load of 80 kips and live load force of 240 kips, and you have two C sections you can see here. And from the cross section view you can see that there are two C section, one is this and another one is this, and in between you have this one which is gusset plate, and the thickness of gusset plate is 1 inch, and all material is of A36, and the bolt diameter is fixed which is 3 by 4 inch, and it is of ASTM A325, and holes are standard holes, and a connection is of bearing type connection, and at the uh, what can I say, friction where the shear failure occurs, they at that place the threads are excluded. So at uh, section where shear failure occurs, there is no threads of bolts, and use three lines of bolts. So one, two, three lines of bolts. You just need to find out how many bolts you will just use for the design. So this is your gusset plate, and at the upper portion you have a C section, and at the rear part you have another C section, and we'll have to determine the number of bolts and the spacing of bolts, and this LR in between spacing, and this LE is edge spacing. We'll find uh, these things also. So at first, what we do is we find the design force. We find design force. In this case, we'll use LRFT method. So design force will be 1.2 multiplied by 80 kips, and 1.6 multiplied by 240, and you will get a value of 480 kips. Well, now we'll find out the shear strength of each bolt. And for that we have a formula that is phi. It is actually the after using the reduction factor, and this is phi 0.5. You can use 0.5 when your threads are excluded from the shear planes. If your threads are in the shear plane, then you'll use the factor as 0.4 fu, and then you multiply it with m and ab. Here m is number of shear plane and ab is the cross-sectional area of your bolt. So let's find this. So your phi value is 0.75, and yours is 0.5, and for fu, for ASTM A325, your fu would be 120 KSI, and your number of shear plane is 2. This is one shear plane, this is another shear plane, so 2, and you have a cross-sectional area of pi by 4, and the diameter is 3 by 4 squared, and you will get a value of 0.4418 square inch, and you will get a value of 39.762. So each bolts can withstand this much of shear force, and your design force is 480. So how many bolts you need? So number of bolts will be the total force or divided by the shear capacity of each bolt, which is 39.762, and you will get a value of 12.1. So you can use a 12 bolts layout. This is one thing. Uh, in this way, you can find out the number of bolts you need. But when you are selecting number of bolts, you will have to go through several checkings. That is, you'll have to find out the bearing capacity of this this channel, and the gusset plate. When you are designing a connection, you have to make sure that the bolts are sufficiently strong, and same time you have to make sure that the other materials, in this case that is gusset plate and C-section, are sufficiently strong also. So we'll find bear capacity of channel firstly, bear capacity, bearing capacity of channel. For that, we have a formula of phi Rn is equals to 2.4 FU dt. In this case, sorry, there would be a phi. Phi is a value of 0.75, 2.4, and your Fu value is, since your channel section is using a material that is A36, so your Fu value here for A36 is 58 KSI, and you need the D value. So what do you mean by D value? It would be fine if I could zoom, but D value means this dimension right over here, the diameter of. Let's zoom a little bit. Here D value means, uh, still it is pretty small. D value means the diameter of bolt, and T value means, yeah, since we are doing it for channel, T value means the thickness, which is this TW, thickness of your channel, which is this value right over here, this value. So your D value is, which is the diameter of bolt, and your T value is given, TW is given 0.673, and you'll get a value of 52.7 kb. So the thing is that for since you are using 12 bolts, so you have 12 bearing surface for channel at the front part, and at the rear part you have another 12 bearing surface. So the bearing capacity of channel would be 52.7 multiplied by 24, which is 1265 kips, and which is greater than the external loadings, which is 480 kips, what we are designing for. So the bearing capacity of channel is okay. Now we'll find out bearing capacity of gusset plate. For that, we have the same formula, which is phi Rn is equals to phi 2.4 Fu dt. So in this case, phi is also 0.75. You have 2.4 as a formula, and you have Fu value of, since it is the same thing, A36, so Fu would be 58, and you have a D value, in this case, that is the same as bolt diameter, but the thickness of channel is 1 inch, which is given right over here. So so eventually you will get a value of 78.3 kips, and your total bearing capacity would be, for gusset plate you have just 12 bearing surface, because the gusset plate is this, and it's just a single gusset plate, so it has 12 penetration of bolts. So you will just multiply the value 78.3, sorry, 78.3 with 12, and you will get a value of 939 kips, and which is greater than the external loadings. So the next part is we'll find out the spacing of bolts. For spacing, we have two types of spacing. One is edge spacing, and another one is in between spacing, like this. So these are L, and these are edge spacing, that is LE. Let's say, uh, for LE, the minimum value is 1.25 inch or 1.5 dB. In this case, dB is 3 by 4. So for that, you'll get a value of 1.15. So your controlling value is 1.25. So you can say that the LE is 1.25 inch. And your L value would be, typically the minimum one is 2.67 dB bolt diameter, but we prefer to use 3 dB. So in this case, 3 dB would be 3 by 4, and the value would be 2.25 inch. So we can lower round it to 2 inch. Okay, for the spacing we have selected, we'll have to check the critical length or spacing requirements by AISC. Let's say for channel, this check is carried out because the connection may fail as a result of tearing out. So we need to have a minimum spacing so that the uh, tearing out is resisted, so that we can have a better strength. So for channel, the edge spacing is equals to P over phi Fu T. In this case, the L edge spacing is 1.25, and you will find out the value of P, which is the load, and phi is 0.75, and Fu is 58, and thickness of channel is 0.673, and you will get a p value of 36.59 k. And for L value, which is uh, 2 inch, 2 inch, you have p over phi, which is 0.75. That would be multiplied with the same thing, 58 and 0.673. But here there is one extra thing, that is this L value, which is in between spacing, have another parameter, that is uh, half dn, and by dn we mean the bolt diameter, which is 3 by 4, plus the clearance, which is in this case, let's say 1 by 16. It is assumed. From here you'll get a p value of 46.66. So so what do we understand from here? So this actually says that if we go right over here, it says that these and these, I think these three or anything else, we have total 12, 12 one, 12. So we have total 12 boards, and amongst 12 there are three boards. For them we find Eli, and the bearing capacity, and the capacity would be, for the boards which are at the edge, it has a capacity of 36.59, and there are three boards at edge. For the front plate, and there are nine bolts, that has a capacity of 46.66, and you have two plates. One is at front plate and the other one is rear plate for channel. So you multiply it with 2 and you will get a capacity of 1059, which is greater than 480 kids. The thing is that it passes the requirement. So it is quite boring to do the calculations, which will not bring any changes. Well, we'll do the same check for cassette plate. We do this check so that the connection doesn't fail as a result of tearing out. And each distance was 1.25, and we'll find out the p value, and we have 0.75. You have the same material, that is 58, and you have a different thickness, that is 1. So from here you will get a p value of 54.38 kips. And the other one, that is for the middle boards, that has a spacing of 2 inch. For that we have this formula, 0.7558 1, and we have a p value of, let me calculate, 2 times 0.75 times 58, 2 times 0.75 times 58. It should be multiplied with that one, that is, sorry, added by this one, like, forgot, like plus half of 3 by 4 plus 1 by 16. From there you'll get a p-value of 69.33 kips, and for that you'll find a bearing capacity of. So it has a single plane for gusset plate, and you have three H bolts, and for that you just multiply 3 with 54.33, I guess that is 33, and you'll multiply the other 9 bolts with 69.33, and you'll get a value of what? Let me calculate. That is 3 multiplied by 54.33 plus 9 multiplied by 69.33. That is 786, which is greater than 480 kips. So from here you can say that the edge distance, which is 1.25, the in between distance, which is 2 inch, is okay. So for this one is 1.25, and these are 2 inch, 2 inch, 2 inch. This one is 1.25 inch. There might be a doubt, that is we have 6 edge bolts. Yeah, that is 6 edge bolts, but for these 3 edge bolts right over here, you have a continued section, so these are not actually edged, so it will have a, I think, full capacity. So you need not to uh, consider 6 edge bolts, you just consider 3 edge bolts, I guess. I don't know the detailed thing, but we consider 3 edge bolts, and the bolt will have a heavy spacing like that, and the number of bolt would be 12. So